Hello, I'm Nick Humfrey. I need to stand central, don't I? I work for the BBC, but this I'm talking about a personal project. And to start off, I guess most people know what Arduino is, but when I've gone around talking about it in the past, I found not everyone did. So Arduino is a small microcontroller and as well as integrated development environment. So it's targeted at novice users, but what I like about it is that it gets rid of all the complexity associated with developing hardware and electronics and just makes it really simple. So there are, when you say Arduino, there are a hell of a lot of Arduinos out there. Special ones you can sew onto things with Linux coprocessors running OpenWRT. But this is the one that I'm really interested in. It's kind of the original. It's gone through some variations, and it's a fairly simple 8-bit microcontroller. This is the one that got me really into it, though. It's called a Nanode. It was available as a kit, and you can solder it all together. So quite impressive of what you can do just through using through-hole components. And this kind of shows how simple it is. This is the very minimum you need. It's the microcontroller, the crystal, a pull-up resistor on the reset, and that gives you a working system. So very different to something like a Raspberry Pi that has some really difficult components to surface mount components to solder. And this is what you can do on a breadboard. You can just put the microcontroller on and flash an LED. So this is a diagram from Shrimping It. So they hold workshops that kind of can show you how easily you can put together a microcontroller like this. And it's also cheap. So in the Arduino's official ones can cost kind of £70, which seems a bit bonkers when you can just buy a Raspberry Pi, which has far more performance. But if you get the individual components, an Ethernet controller like this on eBay is literally a couple of pounds. And how minimal is minimal? So on these 8-bit microcontrollers, it's 32K of program memory and 2K of RAM and some EEPROM for storing stuff in as well. So when I tell people about this project, the first question is usually, why on earth would you do that? It's a hobby. This isn't work. It's an experiment. A personal challenge. 32K of ROM and 2K of RAM is not very much. It was a chance for me to learn about IPv6 at a proper low level, and I'm also interested in the reality of trying to run IPv6 on something really small. When people say it uses up more space, how does that actually compare with v4 on a really constrained device? And also reduce the number of IPv6 excuses. That if you can run it on a device like this, then there's really no excuse at all on a proper device. Does this already exist? Sort of. So micro IP, which became part of Contiki, exists. That's a very generic library that you can run a lot of different devices, and as a result, it can be quite complex to use. That was available as a micro IP Ethernet. There's also various descendants of the Arduino Pico IPv6 stack. They're quite hard to get working at or use up a lot of space, so there's not much room for anything else. And there are Arduinos that actually are running Linux, so that's kind of cheating in my mind. So what I implemented? So this is the feature set and the order I implemented it. So stateless auto configuration. Pinging was a pretty exciting moment when you can send a ping. Next level of complexity is creating a UDP server, and then a UDP client was slightly harder, and then on top of that a DNS client. And finally I implemented a fairly hacky but amazing that it works as stateless HTTP server. So it's optimized for Arduino. The goal is for it to be easy to use. That's what Arduino is all about. It should work within the constraints of an UNO. It should avoid using complex C features like pointers, pointer arithmetic, and callbacks, and try to decouple from the core protocols wherever possible. So what I mean by that is if you just write a really basic example, it doesn't end up pulling in the whole code base. It only links the bits that are needed. And I've also tried to only use statically allocated memory, because when you've only got 2K of RAM, you don't really want to waste any of it with dynamic memory allocation. So this is a basic example. In Arduino, you don't have a main function, you have a setup and a loop function. So the setup function gets called once, and then the loop function gets called forevermore. So in this, we're setting up, there's no MAC address EEPROM on many of these devices, so you have to set one yourself. So this is a administratively configured one. Set up the serial port, start the Ethernet, and then it will print out the global address if it successfully got one via stateless auto configuration. And then it sits receiving packets forevermore. So when you do that, this is the result, and you can send pings, and as I mentioned, that was a pretty exciting moment when I actually got a ping back. Going on to a UDP server example, so this is the setup, just gets networking up and running. And then this is what the packet loop looks like. So after it receives the packet, it checks to see if it's a UDP packet that's intended for this device and port, and then checks the payload to see if it's on or off, and it turns off an LED, turns on or off the LED, and sends a reply saying I've successfully done that. And if you send it something else, it replies with error, so you have some kind of feedback as to what's going on. This is an HTTP server example. So my background is normally on kind of higher level things like Ruby and Sinatra, where you can create kind of your routing of HTTP into functions. So this is a kind of similar approach where you're checking the incoming request, see if it's a GET request of a slash. If so, return with some HTML saying hello world. Otherwise, if you're getting slash text, then return with some plain text. Otherwise, send back 404 not found message. And what have I done with this? I've IPv6 enabled my boiler, because that's the obvious thing you would next do. So on the left-hand side is the Arduino and electronic control, and then on the right-hand side is the relays are actually switching on and off the bits of the heating system, the network sockets on the right-hand side. And because all things fail, I also have some manual controls, so I can stay warm in winter. And this is what the user interface looks like. So the CSS is actually served from elsewhere, but when you're pressing the buttons on the web page, it really is actually sending HTTP requests to the Arduino and turning the relays on and off. So what were the challenges? Tiny amounts of RAM are ridiculous. It's just enough for a single frame of Ethernet. So managing that was hard work. Keeping the code base small, again, the 32K seemed to go much further, but if you actually want to use it for a real-world application, there has to be room for other things as well. Making the code easy to read and write was an important part of doing it for Arduino. That was challenging. I had to do some refactoring and debugging. Far more used to working on a PC or server or something. Debugging embedded hardware is far harder work, and particularly if you're refactoring code, making sure you haven't broken something at the same time as fixing something else. So I quickly actually started writing unit tests, because it was the easiest way to make sure that it was actually doing what I wanted it to do still, without having to burn it all to a device and running it. So what's next? Creating a TCP client is pretty hard work. but I'd love to have basic HTTP working, and MQTT is a pet protocol of mine, so I'd love to get that working. Co-op seems very fashionable, so have a look at that, and also being UDP-centric, much easier to get working on a small constrained device. And over-the-air updates, so being able to reprogram the device remotely would be fantastic, but writing to the memory of the running program is slightly scary, to have to work out the best way of achieving that. So if you're interested in giving it a go, then it's on GitHub, it's open source, freely available, and or if you've got any questions, please do get in contact. So any questions?
Hi, Charlie from Fluency. Have you experimented at all with running this on Zigbee, 802.15.4?
No, I haven't. There have been some other people who've done that, though. So there are Arduino IPv6 implementations for Zigbee. My focus has been more on Ethernet. In particular, I guess if you've got a 10-year battery, it's one thing, but wandering around the house replacing AA batteries is not my idea of fun, so I would rather do power over Ethernet.
I think it was more for sort of sensor networks and things like that.
Yeah, absolutely.
Arduino is perfect. It's just typically trying to use Zigbee in a small form factor like that. You end up doing it on a Raspberry Pi, which is higher power and all the rest of it.
Yeah, there's lots of lower WAN stuff of Arduino as well, which seems like a pretty good idea.
Okay, any other questions for Nick? Tim at the front here.
Hi, Tim Jones. So at the start you were talking about comparison to v4 and footprint and so on. I didn't notice much analysis of that. Do you have any conclusions on that yet?
It is pretty similar. The underlying the kind of address sizes and things like that didn't really come into it very much compared with just all the code to actually do all the hard work. So from that point of view, the proof was it's possible, and ended up with smaller program sizes than some of the v4 counterparts. Not because v4 was, not because v6 can make it smaller, but just the optimization of the coding is far more important than the protocol.
Yeah, so, for example, one of the ongoing interesting discussions, for want of another way of putting it in the ITF, is SLAAC versus DHCP for constrained devices. So you haven't done a DHCP client, for example.
Yes, and so yes, it would have taken a lot more code to implement DHCP than SLAAC.
Yeah. Okay.
Okay, Tom.
Tom Hill from ByteMark. Just a very quick one. One of my colleagues is watching on the webcast, and Ian Chilton, and he's quite eager to know if you have evaluated the ESP8266 as an alternative piece of hardware.
I have one sitting in a drawer and haven't tried it yet. I guess see my previous comment about being a big fan of Ethernet.
Fair point.
Is that a polite way of saying I'm a big mouth? I'll take that. Did you look at BeagleBoard at all? Which is
BeagleBoard?
Yeah.
Yes.
and ruled out because, well, I mean, it's a pricey component, I guess.
Yeah. So I guess it's if you're running a kind of full, you can run full Linux on that very easily. I guess part of this was not so much actually looking for tangible solutions and more keeping myself entertained.
Okay. It's cool though. I like it.
Okay, thank you, Nick.